Hello students, today we are going to explore how to bisect an angle using a compass. This topic will help unlock your skills in manipulating the way we look at angles in a given figure. Our roadmap for this lesson is as follows. We will begin by understanding what it means to bisect an angle. Next, we will learn how to use an essential tool for this operation, a compass, a perfect device to maintain a constant distance. We are going to walk you through a step-by-step process to bisect an angle. This might seem a bit of a task now, but trust me, it is going to be a fun exercise. Finally, towards the end of the lesson, we will delve into why this method works, examining the underlying principles of constant distance and how we use a compass to ensure this accuracy when bisecting an angle. By the end of this lesson, I assure you that you will be adept at bisecting an angle using a compass. It's a handy skill that holds great importance in various mathematical problems and geometrical constructions. So how does this lesson build on what we have learned so far? Well, what we will cover today builds on our knowledge of angles as a measure of rotation or turn. Remember, angles are created by two intersecting lines or line segments. These lines or line segments are referred to as the arms of the angle, while the point of intersection is known as the vertex. The degree of the angle tells us how much turn there is between these two lines. If you're unsure on these previous learnings, make sure to go back and watch the lesson titled Degree Measures from earlier in the module. Now let's turn to our first lesson objective, which is understanding an angle bisector. We typically think of an angle as an arc or space between two lines that meet at a point, also known as the vertex. When we bisect an angle, we simply create a line, a bisector, that cuts or divides this angle into two equal halves. So, put simply, to bisect an angle means to divide it into two equal parts. But how do we make sure these two parts are perfectly equal? This is where our handy tool, the compass, comes into play. A compass is a tool with two ends. One has a needle end, and the other side has a pencil. By placing the needle at a stationary point and rotating the compass, we can maintain a constant distance, which is crucial in the bisection process. So how do we use a compass to construct an angle bisector? Let's take an angle ABC, where B is the vertex, and AB and BC are the arms of the angle. Step 1 is to place the needle end of your compass at the vertex B and extend the compass to about half the length of line BC. Rotate the compass slightly, making sure to keep the needle end stationary at the vertex. To make a mark on this line, let's call the point where this mark touches the line D. Step 2 is to do the exact same thing on line AB, keeping the compass at the same width and keeping the needle at B. Do the same for line AB. Let's call this point E. Now for step 3. Move the needle of the compass to point D on line BC. Use the pencil end to make a mark somewhere between lines AB and BC. Step 4 is to do the exact same thing on line AB. Place the needle end of the compass at point E and the pencil end in the space in the middle of the two lines. Draw a similar mark somewhere in the middle of the two lines. The marks you made from points D and E should intersect. Let's call this intersection point F. Step 5 is our final step. Use a ruler to draw a line from the vertex point B through point F. This line is the bisector of angle ABC. It divides the angle into two equal parts. So that's a step-by-step explanation of how to bisect an angle using a compass. Well done! Remember, practice makes perfect. So try bisecting different angles using a compass and see how it works. So let's turn to our final aim for this lesson. Why does this method work? The reason this method works is because the compass helps us maintain a constant distance. The points D and E are equidistant from B. We know this because we kept the compass the same width when we drew both lines. We also know that point F is equidistant from E and D because we kept the compass the same width when we made both marks. So by drawing arcs from points D and E that intersect at F, we are essentially finding a point that is equidistant from the arms AB and BC of the angle. This ensures that the two angles we get when we draw a line through F are equal. In today's lesson, we learned that bisecting an angle means dividing it into two equal parts. We learned how to use a compass to achieve this by maintaining a constant distance and drawing arcs that intersect at a point equidistant from the arms of the angle. This intersection point, when connected to the vertex, forms a line that bisects the original angle. This method works because the compass helps us to maintain a constant distance.